IOE 413, Game Theory in Healthcare Study Guide. This question asks you to create the dual of the linear program that you see here. Let's do this following the 6-step process I introduced in lecture notes. Let's do step 1. As you recall, step 1 consists of writing our problem down in pseudo-matrix form. So we have max z is equal to, and we'll write down the cost coefficient row vector here, 0, 0, 1, times a column vector x1, x2, and w, such that, and I will write this down just so I can format it correctly, x1, x2, and w. And then we have a 3 by 3 matrix here that's 1, negative 1, 1. I'll put an open bracket there. And we go negative 1, 1, 1. And then negative 1, 0. And we have greater than or equal to, greater than or equal to, and equal to. The third is an equality. On the right-hand side, we have 0, 0, 1. And we have x1 is greater than or equal to 0. x2 is greater than or equal to 0. And w is UNR, or unrestricted in sign. So that's step 1, making the pseudo-matrix form. Now step 2 is really simple. So you'll recall step 2 consists of making dual variables and associating them with the primal constraints. Pi 1, pi 2, and mu. Okay, and you'll notice that there's nothing that's specific to tell us how we should name our variables. I could have done this pi 1, pi 2, pi 3. I chose it pi 1, pi 2, and mu because I'm thinking ahead to the end of this problem and how I want to write it in a way that will make it look like, in a similar way, to something that we'll want to see somewhere else in our study guide. So that's how I chose the dual variables. It could have been alpha, beta, gamma. It could have been a whole bunch of different things. It could have been mu1, mu2, mu3. I chose pi 1, pi 2, and mu. Now let's do step 3. Step 3 is constructing the dual objective function. And that is, if we have a maximization problem, the primal, the dual is minimize. We'll say v is equal to, and then we do 0 times pi 1 plus 0 times pi 2 plus 1 times mu. So we have 0, 0, 1 times pi 1, pi 2, mu. And that's our dual objective function over here on the lower left. Let's do step 4. Step 4 involves making the dual constraints. The first dual constraint is driven by the first column of the constraint matrix, 1, negative 1, 1. That's pre-multiplied by pi sub 1, pi sub 2, mu. And the right-hand side is the cost coefficient associated with x sub 1 in the primal, which happens to be 0. So recall that our primal we're working with is maximization problem. The sign restriction on x sub 1 is greater than or equal to 0. That is going to drive our inequality on the first dual constraint. So let's look down at this maximization column to the sign restriction here of greater than or equal to 0. Go over to the right, and we get that the constraint is in the form of greater than or equal to. Consequently, we have greater than or equal to as the inequality for the first dual constraint. Now let's do the second dual constraint. It comes from the second column of the constraint matrix in the primal, negative 1, 1, 1. Let's pre-multiply that by pi sub 1, pi sub 2, and mu. And then the right-hand side of this constraint is the cost coefficient for x sub 2 in the primal objective function, and that is 0. The direction of the inequality in the dual constraint is driven by the sign restriction on the corresponding primal variable, which is x sub 2, which is greater than or equal to 0. Remember, we had a maximization in the primal. If you look at the, go down the column to the sign restriction, it's greater than or equal to 0. So we have over here on the left. Let's traverse over to the right and see that the constraint for the dual is the greater than or equal to form. Thus, the inequality here is greater than or equal to, and that's the second dual constraint. Now let's do the third dual constraint, and that comes from the third column of the primal constraint matrix, negative 1, negative 1, 0. Pre-multiply by pi sub 1, pi sub 2, mu. And the right-hand side is the cost coefficient on w in the primal, and so that's a 1 on the right-hand side. To figure out whether this constraint has a greater than or equal to, less than or equal to, or equal sign, we recall that the important thing here is that w is unrestricted. Okay, so for a maximization problem in the primal, we go down to the variable sign restriction actually is unrestricted or unconstrained, same thing. And go over to the right, we see that the equality is the appropriate form for our dual constraint. Consequently, we have an equality sign right here, and that is the third dual constraint. Let's do step 5, which consists of determining the sign restrictions on the dual variables. And that's driven by whether the primal is a maximization or minimization. It's a maximization problem here. And the direction of the inequality in each of the corresponding primal constraints. So pi sub 1, the sign restriction on pi sub 1 will be driven by whether it's a maximization problem and that the inequality is a greater than or equal to in the corresponding constraint. Pi sub 2 will be driven by the fact it's a maximization problem and we have greater than or equal to. And mu will be driven by the fact it's a maximization problem and we have an equality. So let's do the sign restriction on pi sub 1. We have a maximization problem. The corresponding primal constraint is of the greater than or equal to form, which means we go over to the right and we get a sign restriction of less than or equal to 0. So we have pi sub 1 is less than or equal to 0. Pi sub 2 is also associated with a constraint that is the greater than or equal to form. So we get the same result. It's less than or equal to 0. Now, mu is associated with an equality constraint in the primal. Okay, so we go over there. We get an unconstrained. So mu is unconstrained, or in my terminology, UNR for unrestricted. So those are the sign restrictions on pi 1, pi 2, and mu. Let's put this all together and write down our dual. Minimize. V is equal to mu, such that pi sub 1 minus pi sub 2 plus mu is greater than or equal to 0 minus pi sub 1 plus pi sub 2 plus mu is greater than or equal to 0 minus pi sub 1 minus pi sub 2 is equal to 1, pi sub 1 and pi sub 2 are less than or equal to 0, and mu is unrestricted. Now, let's do step 6, the check. There are 2 simple checks we can do. The first is, if the primal is a max, the dual is a min, check, that's okay. The second easy check is to make sure there are no primal variables left in the dual formulation. Well, the primal variables were x's and w. I don't see any x's, x sub 1 or x sub 2, or any w's here, so that's okay. The third check we can do, which is too time consuming to go back and do here, but is a good thing for you to do on your own as an exercise, is to create the dual of this dual, and you should get back the primal. That's the answer for this question.